So hello everyone, John here. Well, in this video we would like to talk about the central angle in a circle. Well, you know that, let's say this is a circle, and I hope this thing works, because so if this is a circle, something like this, and you basically let me see. Oh, this pen is kind of sometimes not very cooperative. So no, not working. Still. There is a bit of problem with this thing. So okay, now it's working for now. Well, if you have a circle, in this circle you have a you could have an angle. First of all, any circle has 360 degrees, is a full 2 pi angle, and basically the unit circle was coming from we were having it using a circle as well. And now let's say this is the center of the circle, and if we have an angle like this inside this circle, something like this, and also, well, let's say we have this angle over here, and I'm going to call this theta, and this, as you know, is the radius of the circle. This is the radius of the circle, and the length of this arc subtended by this angle theta, I'll call it A. So in this circle, you know that in any circle there is 2 pi, there is an angle of 2 pi radians. The whole angle inside the circle. Now, sometimes you don't get what you want here, but well, okay. Now, no, sorry. So, where's my eraser? So inside the circle you have an angle of 2 pi degrees, and you know that the arc subtended by an angle of 2 pi degrees is basically the whole circumference of the circle, and the whole circumference of a circle is basically measured by 2 pi r. You know, we already know that. Now, the arc subtended by the angle theta, we said that it's A, the length of the arc, and the angle is basically theta. So now you can form a ratio of these 4 values over here, and then you could then somehow get the values of r, A, and theta. You could have 3 formulas over here. And how that works is you could basically say, in any way, in any case you have to form a rational ratio between these 4 values. For example, you could say that the ratio of an angle of 2 pi by the arc subtended by that angle, by the angle 2 pi, is equal to, let me write that down. So I can write that the ratio of an angle 2 pi, the ratio of this angle to the arc subtended by this, which is basically 2 pi r, is this could be equal to, and so now, because I'm talking about the same circle, I can write this could be equal to the angle theta and the arc subtended by that, which is a. So now you have a ratio, and now you can solve for anything that you want here. And so based on this, you can write 2 pi a is equal to 2 pi r theta. Basically, you multiply this into this, and then that would be equal to this multiplied by this. So this works like this. And then you can get rid of 2, and 2 you can simplify. Pi can be simplified as well. So as a result of that, you have a is equal to r theta. We could call it equation number 1. And now you can basically calculate anything that you want here. For example, you have a is equal to r theta. You want to calculate r, you can write r is equal to, based on 1 of course, based on equation 1, r is equal to a divided by theta. I can call it equation number 2. And again, based on 1, you can say that theta is equal to a divided by r. And so now you have 3 equations with which you can calculate anything you want in a circle. Now let's use them in, but before we get to any examples, you can now here, based on this, well, basically you know that theta in these equations is always in radians. It's not in angles, it's always in radians. So now based on this, you can basically get a definition of 1 radian. 1 radian would be, if a was equal to r, then you would basically get a value of 1 for theta. Let me write it down here. If a is equal to r in 1, for example, then we would have, you could substitute a for r or r for a, doesn't matter. Equation number 1 was a is equal to r theta, and then substituting a for r, we will get a for r in 1. We would get r is equal to r theta, and so theta would be equal to r by r, which is equal to 1. So basically an angle of 1 radian, it would be you could say that an angle of 1 radian is the angle subtended at the center of a circle by an arc equal in length to the radius of the circle. It basically means that if you had a circle like this, I mean that basically only that that portion of the circle that we were talking about. Basically I'm talking about only this portion of the circle that we were working on. So if I had only that portion of this circle in here, it would be something like this. And let's say, well, it's not very precise, but you get the idea. If this is R, this is the center of the circle, and this is again R, and this is A. Now if A is equal to R, then this angle theta is 1 radian. Then theta is equal to 1 radian. So it means an angle of 1 radian is basically any angle in the center of a circle, which has radius r, and also the length of the r subtended by the angle theta is also equal to r. So that's basically what that means. So now in the next video, I think we don't have much time here left to do an example, but in the next video we're going to use these formulas 1, 2, and 3 in order to solve a few problems, see how that works. So thank you, and I'll see you in the next video.